Show the step-by-step mechanism for the dehydration of 1-butanol to 1-butene and the mechanism of E1 because 1-butanol is a primary alcohol. Okay, so CH3, CH3, CH2, CH2, it's an OH. We're going to spell out the hydrogens on that beta carbon, so H and H. Okay, so dehydration, we need an acid with a bulky base, so that's either phosphoric acid or sulfuric acid. So H3PO4 is our acid. You can use H2SO4, and usually the reaction requires heating. And what you get is this CH3, CH2, CH double bond CH2, and a side reaction is you produce water. Okay, because it's dehydration. So step 1. CH3, CH2, CH, CHOH. That's 1-butanol. Okay, H3PO4 is an acid. So in solution, it's gonna dissociate into H plus and H2PO4 minus. Alright, so then one of the lone pairs on oxygen grabs the H plus. This is what you get: CH3, CH2, CH. Now on the oxygen we have now 2 H's and 1 lone pair. Before we had 2 lone pairs and the H plus was not part of the structure. Now we have 2 H's on the oxygen and a lone pair, and now we have a plus charge on the oxygen. That's step 1. Of course, you still have H2PO4 minus. And step 2, so the product, the reactant in step 2 is the product in step 1. CH3, CH2, CH, CH, OH, lone pair, positive charge. Okay, so oxygen is not happy being positively charged. So what will happen is this H2PO4 with a negative charge is not a very strong base, but it's basic enough to remove an H off of that beta carbon. Remember, this is the alpha, this is the beta carbon. Okay, so when the H2PO4 removes an H off of the beta carbon, this bond forms a second bond between the beta carbon and the alpha carbon, and this bond between the oxygen and the carbon goes to oxygen as a second lone pair. And now you have your product: CH3, CH2, CH, double bond CH2, and in the process we produced H2O with 2 lone pairs. So H3PO4, the H plus was used up, and then later on it was regenerated, H3PO4. So we say that H3PO4 is a catalyst. Initially it gets consumed, but then it gets regenerated. So overall it doesn't get consumed.